Hi, welcome. My name is Doug Shook, and I am so thrilled to be here. I absolutely love teaching this class. I'm so excited to get to know all of you. Let me just introduce myself real quick before we get started. This is the 6th course, I believe, that I've taught for Launch Code. So I've been doing this since 2015 or 2016, and I've loved every single one. We're in for a lot of fun over the next 20 weeks. My day job is also teaching, actually, over at Washington University in the computer science department. So teaching's my life. I do it all day, every day. I have to say, though, that Launch Code I really, really enjoy, probably even more so than my day job. Don't tell my boss. Which brings me to my next point. I shouldn't say stuff like that because I am recording right now. I record all of my lectures, so if you do have to miss a day, which I understand is probably going to happen for some of you from time to time, or even if you do come to class and you're just like, what the heck was he talking about that one time? All the videos will be uploaded to my YouTube channel after class is over, and I'll usually post a link to that in Slack too once I get around to it. So I just like to make people aware of that because that does mean when you ask questions and such, you're also being recorded. So I just want you to be aware that that's going on. And so Brian already did a good job of explaining what's going to go on with class. I just wanted to explain things from my perspective, some of which is going to be a little bit of a review. But you're already familiar with Canvas, which is this page right here. Mine might look a little bit different than yours since I have the instructor view of the page. But regardless, the content is largely the same. Every class is going to have 2 items. So there's the prep work, which hopefully you've already done. Not all of the prep work is going to look this long. It's the first day of class, so we asked you to do a little bit extra to get ready today. And then there's the in-class section, which oftentimes is going to explain the studio or it might explain a problem that I'm going to go through in class. So don't feel like you need to look at this before you show up. It's not as important as the prep work. The prep work is really the important thing that you should be checking out before you show up to class. And then what I like to do, and what I'm about to do here in just a moment, actually, is go through some review questions. I actually like to ask you guys questions. I'm going to ask you lots of questions to check your understanding of the prep work. So please come prepared to participate and answer questions. And then, of course, there's always plenty of opportunities for you to ask questions as well. I am not afraid to go off on tangents. I'm happy to dive down the rabbit hole of any topic that you might be interested in, time permitting, of course, if we have enough time to do so. Yeah, come ready to talk about that day's prep work in any shape or form. And so let's just go ahead and get started. Let's talk about some code. We've spent almost an hour talking about not code, so let's talk about some code stuff for a little while. That's why we're here. All right, review questions. I believe it's from chapter 1 of the prep work. Can somebody explain to me what an algorithm is in a sentence or two? What is an algorithm? It's a sequence of what? Sequence of steps? Sure. Instructions? Yeah, I like that word a lot. Sequence of steps, instructions that tell you how to do something, right? Tell you how to perform some action, right? So then what is a program? I'm sorry? A series of algorithms to achieve some goal. So algorithms and programs are very tightly linked together. I do like that part of your answer, but I would take that a step farther. Take that one step farther, yeah. Yeah, so bringing the computer into it is really important for the program, right? Algorithms exist independently of computers. We could talk about algorithms whether computers existed or not. Algorithms are a more theoretical concept, I suppose, right? A program is when you're actually giving instructions such that a computer can accomplish a particular algorithm. So step by step, it's a more concrete, right? More concrete implementation of those instructions. And so then the last question you see up here, what is a programming language? We're going to be using Python in this class. Yeah, over there, sorry. Yeah. I love it. Yeah, absolutely. You said the word syntax. I'm really glad you used that word. Human languages also have syntax, right? There's things that people say in particular orders. They have grammars. Same's true for programming languages. There's a lot of overlap. And so just like there are many different kinds of human languages, I'm speaking English right now. I know enough French to make it sound like I don't know any French. And, you know, there are many other languages in the world. The same is true for computing. But there are some big differences between computing languages and human languages. For example, computers like to be very explicit about things, whereas humans can oftentimes infer what people mean. Computers do not like ambiguous statements, so things that could be interpreted in multiple ways. Computers don't like that. Whereas humans, we say stuff like that all the time, right? And people just kind of naturally gravitate towards what you expect the meaning should be. For example, my favorite example is the sentence, children make delicious snacks. Probably 99% of you thought about kids making some peanut butter and jelly sandwiches, and then there's a couple of you out there who thought about eating children. Your secret is safe with me. I won't tell anybody. But that's an example of an ambiguous statement, right? It's also general. A computer would not like that statement because it's also not explicit enough. What children are making snacks, right? We, as humans, we can talk about that in an abstract way, whereas a computer wants to know, what children are you talking about that are making these snacks right now, very explicitly. So that's just kind of the world that we're entering as programmers. We need to learn how to communicate to a computer, which sounds kind of silly, but it's true. A programming language exists to help us communicate with the computer. If computers ruled the world, which may happen someday, but not right now, but if they did, what would computers use to communicate with each other? I'm sorry, binary, ones and zeros, right? Ones and zeros. That's how computers see the world. Humans are really bad at seeing binary unless you take the right pill and get unplugged from the Matrix, in which case you're good to go. That's my favorite movie, by the way. First Matrix reference of the course will not be the last. I promise you. So we have programming languages to help us communicate with computers. And really think about what a programming language is. It's a way for us to write something that kind of sounds like maybe a little bit Englishy, a little bit. There might be some English words in there that gets turned into ones and zeros that a computer then can understand and operate on. The important thing, though, to remember, to take it back to the first question about algorithms, the concepts, the steps that we take to perform certain actions are going to be the same, regardless of the language that we use to describe those actions. For example, right, I make a lot of sandwiches. Sometimes I make peanut butter sandwiches at home, right? Do you think people in France make peanut butter sandwiches? Or people in Mexico? Or people in China? Maybe not as much as I do, but they probably still make peanut butter sandwiches, right? I could explain how to make a peanut butter sandwich in all of those different languages, right? But the steps, the actual steps, are the same, regardless of what language I use to describe those steps in. That's the algorithm. The algorithm is sort of the essence, the actual steps that you perform. We use a language to make that more concrete, to talk to the computer, turn that algorithm into a program which actually does something. Any questions about those concepts before we move on to the next set? All right. What's a variable then? Let's get into some more nitty-gritty details about stuff. What's a variable? What's it do for us? Placeholder? That's an interesting answer. I'm sorry? Stores a value. Yeah, there we go. Stores a value. It's a label. I think of variables as labels. I have this piece of information. So I can give you the number 7, right? And you're like, oh, hey, thanks, number 7. we all understand what the concept of 7 is, but it doesn't actually mean anything by itself. But if I say, oh, hey, this is the number of days in a week, then you're like, oh, okay. That's a bit more meaningful, right? So variables allow us to label our information. They allow us to provide context to the information so that we can have a better understanding of what's going on in our programs. So how do we create a variable? If I wanted to start writing some code, what would I say if I wanted to create a variable? Input. We're going to get there. Not quite there yet. Yeah, there we go. Variable name equals value. That's how we create a variable. Create and initialize a variable, right? That equals sign is a little tricky. A lot of us have seen equals before in math class, probably, right? We think about it in terms of true equality. This thing and this thing are the same thing, right? They're exactly the same. That's not what an equal sign means in this context. It's variable assignment, which is different. It's a slightly different meaning. So when we create some variables and use them in our code, I actually find it easier to evaluate those statements from right to left. I'm going to take whatever value is on the right-hand side of the equal sign, and I'm going to place it in the bucket with a label of whatever the variable name is on the left-hand side of the equal sign. Now, things like equality, true equality, are important to us as well, and we'll get to those eventually, right? But for now, equals means variable assignment. And so then how do we use variables in our code? What are we going to use them for?
Set values for like solving problems.
For solving problems, for remembering things for later. I'm going to spend a lot of work computing this particular value, and oh, I want to make sure that I have that for later when I need it, so I'm going to stick it in a variable, right? Use like pi. Well, pi is oftentimes supplied to us, but yes, pi is a particularly useful variable for us. Really, though, the general answer that I like to give to this question are variables are used to tell a story a lot of times. If I name my variables appropriately and I use them in an appropriate way, they tell a story. I start with nothing, next to nothing, right? And I start creating variables and manipulating those variables over time until I end up with something. And if I track how those variables are created and used in my program, much like reading a book, I can understand the story of that program, what it's trying to do for us. All right, how do we ask the user to give us some information? You had the answer a second ago. This is input. Yeah, this is input. So what is input? Does anybody know? Like, what is that? Is it a variable? It's a function. It's a function, yeah. We haven't gotten too heavy into functions yet. We certainly will. But input is a function. And the function's job is to ask the user to type something into the keyboard, right? And then bring it into, and then bring it into your program so you can use it in your program. What about the opposite? How do we give information back to the user? Print. Print, which is also, it's a function, right? It's a function. So print takes in some information. I can give it a variable. I can give it not a variable if I want to, just type in a message, right? And it will display on the screen so that the user can use it. Now, you might be a little curious, like, I'm sure before today, not many of you have been interacting with computer programs in this way, right? You haven't been typing things into the keyboard and then having text pop back out at you on the computer console. A lot of times you'll have a window with things you can click on, right? Stuff like that. That's called a user interface, and we'll get to those way down the line eventually. For now, this is the simplest way that we have to get information into and out of our particular program. And what's a type? Somebody give me some examples of types. Oh, I heard like all of them at once. It was great. Yes, to all of those answers. Integer, floats, strings, Booleans, I like it. So what's a float? It's got a decimal value, right? What's a string? Text. Text. And we know it's a string because We see the quotes, the quotation marks. That's always a dead ringer that we're using strings, right? What's a Boolean? True or false? Why is that even a thing? That seems like a really weird thing. Well, if statements is certainly an acceptable answer, but not the one I was actually looking for. Binary, yeah, binary. It goes back to that idea that computers do things in binary. Boolean represents a binary digit, true or false, 1 or 0, right? It's a single, if you think about it, it's like the smallest piece of data that we can possibly represent on the computer, true or false. It's as simple as that. They do have lots and lots and lots and lots of other uses that we'll see as we progress through the course. How can we change types then? If I have an int, or let me start. If I have a string and I want not a string, what might I do?
Int function.
The int function, yeah, or the float function, right? There was a third one. What was the third one? I had it up before class. I don't remember now. But that's okay. We have various ways of type conversion functions to take values from one type to another. Is it always going to work? What might cause it to fail?
A string only has text.
Yeah, so strings can have text, but they can also have numbers, right? So that's why it can be a little bit confusing, especially as you're starting out, to think that I actually have multiple ways to represent the number 7, for example. I can represent that as an int. I can represent that as a string in quotes, right? And if I want to convert back and forth between the two, I can, using those type conversion functions. And then there's another way I can represent the number 7 as well. A float, 7.0, right? So that's at least 3 different ways that I can represent the concept of the number 7. So which way should I choose for my programs if I'm faced with that choice? It depends on what you want to do. That's exactly right. It's all about context. Am I going to do some kind of arithmetic with this number 7? Do I plan to do math with it? If so, then int or float is probably the way to go, right? If I don't intend to do arithmetic values, then strings might be okay. What's an example of numbers that you see that we don't ever plan to use math on? Phone numbers, good one. There's another very common one. You can do math with dates. I can add 2 days to today's date and get social security numbers, addresses, zip codes. Yeah. We don't plan to do math on those things. Those can be strings. That's fine. That's okay in a lot of cases. Any questions about variables, data types, things along those lines? All right, I think I got one more set. How am I doing on time? Oh, I'm doing great. I got one more set of review questions. Dealing with errors. So we're getting started with programming. If you did the prep work, I'm sure you probably ran into some errors. It's not going to stop. It's just relentless. It really is. It's not going to stop. So I mean this very, very, very sincerely. I honestly think it's more important for us as programmers, which is what you are now. You are all programmers. You've started writing programs. It's more important for us to be able to understand what kinds of problems can occur and figure out how to fix them than it is to be able to write code correctly the first time. Because I'll tell you right now, you're not going to write it correctly the first time. If I write a program and it works on the first try, I'm like, huh? I'm like, what? It doesn't happen. It just does not happen. So as programmers, this is really important for us to learn what the different kinds of errors are and how to resolve them. So let's talk about the different types. What's a syntax error? Can somebody give me an example of what a syntax error? Missing parentheses, missing quotes. You type in a name of a variable wrong. You just fudge it, right? These are usually the easiest ones to deal with. A lot of times the computer will tell you. The computer is actually smart enough to pick up on these. A lot of times they'll say, this looks weird. I don't know what you're talking about. Oh yeah, I was supposed to capitalize that letter, and I didn't. You know, that kind of stuff happens all the time. Everybody makes these kinds of mistakes. They're really not that huge of a deal. These other guys, the two coming next, can be a little trickier to handle. What's a runtime error? You don't see it until after the program starts to run. right? So that means that the syntax is fine, by the way. If I see a runtime error, that means my syntax is good. The program won't even start if you have a syntax error. It's like if you misspelled something on your English paper, right? The computer's not even going to look at that sentence. It's just going to be like, I don't know what you're saying. You got to spell it right, and then I'll try to read the sentence and figure out what's going on. So a runtime error is, I started reading the sentence and I did what you told me to do, but whoops, something happened. Does anybody have any examples of what that something happened could be that you might have seen? Yeah, in the back. Yeah, you try to use a variable that doesn't exist yet, right? Classic example. Any other ones? Divide by 0. There we go. What would happen if we actually could divide by 0? I don't know. I don't want to find out. We can't do it. It's not possible. That's an example of a runtime error. It might seem like a silly one, right? Like, why would you ever try to divide by 0? Well, if we're using variables, we may not know that our variable has 0 in it. That's part of the deal with variables, is we don't always know exactly what value is in there. So we may end up trying to divide by 0 on accident. What else? Okay, so type mismatching. So like if we use inputs to ask for certain types and we get the wrong types back, something like that. Might see some type mismatch kinds of runtime errors. Sure. In fact, that's going to be a recurring theme for us, especially as we get through Unit 2, is that your users are going to give you bad information all the time. And that means us too, though, right? Because we're also users. We're not programmers and users. We're going to give bad information, and your program has to be able to handle those situations. Last, but certainly not least, what's a semantic error? Yeah, it's the worst kind. You hit the button, everything works, and it spits out the answer. It's just not the right answer. It's the worst. You might also hear these called logic errors. That's actually what I tend to call them, because your code works. There aren't any incorrect statements, but just somewhere along the way you just did things in the wrong order, or you skipped a step, or you just forgot to do something, right? So the computer doesn't know. Computers are actually very dumb, if you think about it. Computers are very dumb. I have to be very explicit with them. I have to hold their hands and walk them through every single thing that I want them to do very explicitly, right? And then if I screw something up, they usually don't even know what's wrong. Like, they can't even tell me what I did wrong. Computers are very, very, very dumb. But they're fast. That's why we use them, right? They're very, very quick. So semantic errors are going to happen. They really stink. What should you try to do when this happens, though? What's the solution to these kinds of errors? Debugging. Good. Debugging. So what's debugging allow us to do? We get to stop our program halfway through, right? And then examine what's going on. What are my variables? What are they doing right now? This variable doesn't quite look right. How did that happen? And then I can try to work my way back to where I screwed up, to where the problem is. We're going to see some examples of the debugger in class on Thursday, for sure. Yeah, these are the kinds of errors all errors that you run into are going to fall into one of these three categories. And the ones that I get asked about, more often than not, are in the last category, although sometimes the second category. If you ask me about syntax errors, then I'll help you, but a lot of times the computer can actually do a good job with that too. Any other interesting error things that you ran into or questions you have about errors you might see? We're going to see a lot. And I'm not going to expect you to know them all either, which is why you're going to see. So for starters, let me be perfectly clear. I'm going to screw up in this class a lot, right? It's just part of the job. I'm going to screw up in front of 180 people on a daily basis. That's okay. Don't judge me, and we'll figure it out. We'll figure out how to solve those problems. That's what being a programmer is attempting to do something cool, failing, and then figuring out how to actually do something cool. So we're going to get used to doing that. we're going to get used to seeing errors and solving those kinds of problems. Okay, let me make sure I did everything that I was supposed to cover. I think I covered all 3 chapters more or less. I did skip some stuff. You'll notice in the review I did not cover exhaustively every single topic that was covered in the chapters. A lot of times I just don't have time. There's a lot of stuff in the prep work. I try to go through and pick out the stuff that I feel is most important for you all, especially in regards to the assignments that we're going to be asking you to do. A lot of times what I would do now, I'm not going to do it today because it's the first day of class and we have a lot of stuff that we need to get done in the second half of class. But a lot of times what I would do now is go through a problem with you all, where I would actually write some code with you as a group. So on Thursday, I'm definitely going to do that. I'm kind of sad I don't get to do it today. It's a lot of fun. On Thursday, I'm definitely going to do that. We'll do a walkthrough of a programming problem, and then I will. After that's done, that's when I shut up and get out of the way and you break up into your small groups. One other thing I wanted to mention, because I saw some people talking about it on Slack, is the textbook. I know a lot of you have been poking around here already, and you'll notice you can change stuff. Like I changed this string here to be my name because I'm vain like that, and I run it, and it works. You got to be careful though. The book does not remember what you do, so if I refresh the page, or if I close the tab and I come back later, you see it's gone. It doesn't remember that change that I made, which for one word is not a big deal, but for a whole program is a very big deal, right? That's annoying. That's really bad. So please, 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 remember, if you're working on problems in the textbook, to hit this save button like all the time. All the time. In fact, one of my biggest recommendations to people is to save every couple lines even. You don't want to write a huge program and then save, because what if your computer crashes or your power goes out or something like that? Yeah?
I just wanted to know, when you do the problem with everybody in class, should you walk on the problem with you?
Oh, great question. The question was, when I do the problem with everybody as a group, are you expected to, are you expected to follow along? And honestly, I'm not a huge stickler about that. If you have a laptop, your computer, you want to bring it and follow along with me, I certainly encourage that. If you want to sit back and treat it as like a demo, I'm okay with that as well. It's really just how comfortable you are with it. A lot of times people feel like they can't keep up with the example, which is, I really try hard to make sure that people can keep up, right? I want to make that clear. I don't want to leave anybody behind, but if you are having trouble keeping up with me, I would suggest to just sit back and treat it like a movie instead of a video game, right? So I don't know what's going on with my projector right now. But anyway, please make sure to save your work often, and then when you save, if you come back later, if you want to see your stuff, you can hit the load button, which there we go. It should load your work back. Now, I do want to make it clear as well, saving does not submit your work to us. If you save something on your computer, I can't see it. I cannot see it. The people grading the assignments and stuff cannot see it. The way that you actually submit assignments to us, at least for Unit 1, is through a system called Vocarium. I'm not getting into that today. I'll do a demo of Vocarium on Thursday. Your first submitted assignments are not due until Sunday anyway, so don't even worry about it right now. You got enough stuff on your plates to worry about. We'll talk about the first assignments on Thursday and do some more code examples on Thursday. My time is about up, but I just wanted to make sure, are there any questions that anybody has? Yes?
How do we sign up this? How do we...
How's attendance taken? Attendance is going to be taken in your teams. So when you break up into small teams, your TAs will take attendance. So, we all have to learn each other's names. That's going to take a little bit of time, but eventually attendance will be taken and you won't even know that it happened. They'll just take care of it for you. Yep. Any other questions before I get out of the way? Yeah, question. Oh, okay. 2 days a week, Monday and Thursday, from 5:30 to 8:30. And all classes are going to follow basically the same format. I'll be up here for about an hour at the beginning, we'll break up into small groups, and you'll do team activities and the in-class problems for the rest of the time. And then around 8 o'clock or so, I'll ask people to regroup, and we'll go over the in-class activity to wrap up the day. Yep. Question? If you save a program in here, I cannot see it. Nobody on staff can see it. The only person who can see it is you. That's it. This is for your benefit only. To submit assignments to us, you have to use a different system, which I'm going to talk about in class on Thursday. Yeah. But still, save your work, please. Often. Often, often. Any other questions I can tackle before I get out of the way? Yeah, what's up?
Just a question. So when we do coding, are we using coding in the book? Like on my computer, I have like Visual Studio and all this other stuff. Like I've been using the past.
Yeah.
Can we use those, or are we only allowed to use like coding on the book?
All right, so let me tackle that. There's kind of two different questions there. For Unit 1, we're mostly going to be using the textbook. Towards the end of Unit 1, we're going to shift you away from the textbook, and then from Unit 2 on, we're not going to be using the textbook at all. And then the second question that I kind of heard you ask was if I want to use something else right now, you're more than welcome to do so. Okay. Right? If you have another system set up on your computer, you want to use that, we don't have a problem with that. Okay. We'll show, for those of you who are not familiar with how to set up a system like that, though, just stick with the textbook for now, and when the time comes, we'll walk you through the process to get your own environment set up. Great questions. Any other questions? Please keep up this level of interaction. I love having a back and forth with you guys. These classes are going to be so much better for everybody if we can have conversations. So please keep them coming. Yeah. My name is Doug Shook. Yeah, great question. It's all right. I understand. I have about 180 names that I need to learn now, so we're all in the same boat today. Yeah. If you have prior experience and you're doing an assignment, so like you want to use a concept that maybe we haven't introduced to the class yet? Is that what you're getting at? Unless it explicitly says something in the instructions, I don't particularly have a problem with that. The only thing that I would ask is, people who are following along with us might feel confused or overwhelmed with having additional concepts injected in, so you might just be careful about how you discuss those assignments with your classmates if that's what you're going to decide to do. We are careful to introduce things in a particular order, at a particular pace is all I'm trying to say, I guess. So, yeah, Vocarium's not going to care. I mean, as long as you satisfy the conditions of the assignment, Vocarium is not going to care how you get there.
So like if we do like our input and changing it to an integer and pick up a line, if we do it in one line.
Vocarium won't know the difference. No, won't know the difference. Yeah. Yeah, go for it. It's all you. It's not always made at 5:30 at night, but sometimes it is. I mean, and if it's not, I think there might be instructions to make some. So
you might want to bring your own mug.
Yeah, and usually too, it's a good idea to see if other people want coffee, so you're not just making a big pot of coffee for yourself. Like, just saying. But yeah, in the back. Mm-hmm.
Yes, I will. That's correct.
Yeah, we're not going to be here on Memorial Day. I'm not going to be here on Memorial Day. I mean, what you guys do, it's out of my control. But
you also will not be here on Memorial Day.
You might be like out at the front door wondering where
Yeah.
everybody is, but you won't be here. Yeah.
With it being winter time, when there is possibly bad weather on a class night.
Mm-hmm. Slack is the place to keep an eye out for that, and we might even send out an email if it's really bad. Yeah.
Generally, we follow the St. Louis Public Schools.
Yeah, we follow St. Louis Public School Corporation. So if they're closed, we are closed. Anything else I can help you with before I get out of the way? I'm sure you'll have more questions along the way. That's totally fine. After you guys split up into your teams, I'm still wandering around. It's not like I go home, right?
That's great.
Okay, yeah. I'll still be here wandering around. So please feel free to stop me, ask any questions you have, or just say hi. Tell me your name. You're going to have to tell me like 10 times before I remember it, but I'm going to do my best. And it was a pleasure to meet you all. I'm really looking forward to it. I'm going to hand the mic back over to Ryan.
All right, I'm going to invite you